Hi, myself is Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss definitions and terminology on organization of a computer. So this is a second module. So we are discussing definitions and terminology. So let's start with the register transfer language. So this register transfer language is a symbolic notation used to describe the micro operation transfers among register is called register transfer language. So this register transfer language is a symbolic notation, and that can be used to describe the micro operation transfers among the register is called register transfer language. So using this symbolic notation, we are describing the micro operation, micro operation transfer among the register. So micro operation is the operation that we are performing on the data stored in register. That is called the micro operation. So nothing but add, subtract. So these are all the different micro operations. So a register transfer language is a system for expressing in symbolic form the micro operation sequence among the register of a digital module. So for any function of the computer, the register transfer language can be used to describe the micro operation. So for any function of the computer, the register transfer language can be used to describe the micro operations. So micro operations are the operations that are performed on the data stored in registers that are called micro operation. So these micro operations are basis for most sequential digital systems. So these are the basis for most sequential digital systems, unlike the operations specified by the assembly language instructions. So these micro operations, it includes several operations that are, the first one is the movement of data from one register, memory location, or IO device to another. So in a computer system, we need to copy the data or transfer the data from one place to the another place. That means it may copy the data from one register to another register, or from memory location to the register, or from the register to the IO device. So that means using these micro operations, we can able to move the data from one register or memory location or IO device to the another device. And second one is modifying the stored value, such as incrementing or clearing the register. So we have a register. Suppose if you take a 8-bit register, if you take 8-bit register, so this is a 8-bit register. So in general, we are storing some data in the registers, and then we are performing some micro operations on the data that is stored in the registers. So modifying stored value, that means we are modifying the value stored in the registers. That means suppose if you have a value 8, so this is a binary representation, and its equivalent decimal value is 0, 8. So if you perform increment operation, then its LSB is replaced with 1, because if 1 0 0, so it is the equivalent to 0 8. If you increment one bit by 1, then it becomes 1 0 0 1. Okay, so this is equivalent to 9. So that means we have performed one bit increment on the data stored in register. Okay, and also clearing the register. So if you clear the register, then the register contents will become all zeros. Okay, so these operations means modifying the stored value. Suppose if you perform increment operation, the value stored in the register gets modified. So that's why these are modify stored values. Third one is the perform arithmetic or logic functions. So, such as adding two values and storing the result in register. So, we have several arithmetic and logic operations like addition, subtraction, multiplication, and division. Similarly, logic operations are AND operation, OR operation, exclusive OR operation, increment, decrement. So, these are all the various arithmetic and logic operations. And then otherwise the modify a stored value such as overwriting the value in register with another constant value. So overwriting, that means already in this register I have stored 08. So this 08 I'm overwriting with some other constant value, that is 45. So that means it is entire the data, it is replaced with a new data. So these are all the various micro operations that we can perform on the data stored in the registers. So first one is a movement of data. Next, modify the stored value. Then perform arithmetic or logic operations. Then overwriting the value in a registers. And then come to the designate of registers. So the register. The definition of register is it is a collection of flip flops. Okay, collection of flip flops. So that means it is a register. Suppose if you consider a 4-bit register, then it can able to store 4 bits of data. So it is storing 4 bits. That means register is nothing but collection of collection of flip flops. Collection of flip flops. So what is flip flop? Flip flop is a single storage device, single bit storage device. That means using this flip flop, we can store either 0 or 1. So in a 4-bit register, we have 4 flip flops, so that we are able to store 4 values. Okay, so that are the registers. So registers are designated by capital letters, sometimes followed by numbers. So that are A. So in general, the registers are represented with A, B. Program counter is represented with PC. Instruction pointer is represented with IP. Memory address register is represented with MAR. Data register is represented with DR. So like that, all the registers are designated by the capital letters and sometimes followed by numbers. So like R13. Suppose if I have multiple registers like R1, R2, R3, R4. So that means I have a register R with the same name. I have multiple registers, so that's why it can be represented with R1, R2, R3, R4. That means the alpha capital letters followed by numerical number. Okay, so finally we can see the registers are designated by capital letters and sometimes followed by the numbers. The examples are A, R13, IR. So often the names indicate the function. So memory address register, it can be represented with MAR. So what is the function of the memory address register? So memory address register, it stores the address of the currently executing instruction. Currently executing instruction. Suppose see here. Suppose if we have a memory, then if the address is starting address is 2000, 2001, 2002, 2003. Suppose if the CPU is reading the instruction from the instruction which is stored in 2000 location. So this address, it will be stored in the MAR, memory address register. Then program counter. So program counter, the definition of program counter is the program counter which stores the address of the next instruction is to be executed. So that means if the CPU is executing the current instruction which is at 2000, then the next instruction is located at 2001. So the instruction which is at 2001 is the next instruction it is to be executed. So that's why the address of the next instruction is to be executed is stored in the program counter. So that is a program counter definition. So program counter, what it will do, it stores the address of the next instruction is to be executed. So after executing the first instruction, the second instruction is stored at the address 2001. So that the address of the next instruction is to be executed is stored in the program counter. Then instruction register. Instruction register. So once the instruction is fetched from the memory, then that fetched instruction is placed in the instruction register. So in general, the size of the instruction register is the 16-bit register. The program counter also, it is a 16-bit register. Memory address register also, it is a 16-bit register. Then the registers and their contents can be viewed and represented in various ways. So a register can be viewed as a single entity, and registers may also be represented showing the bits of data they contain. So the registers are represented showing the bits of data they contain. So we can represent the registers in various ways. The first one is it is the most common way. So the most common way of representing the register is by the name of the register enclosed in a rectangular box. So this is a common way of representing the register. So the registers are represented using a square bracket, square box. Okay, writing the name of the register inside the box. So here the name of the register is the R1. So like that we can represent. So this is the most common way of representing the register. The another way is the individual bits. So that means 0 to n minus 1 can be distinguished as shown in figure. So suppose if it is a 8-bit register, it is a 8-bit register. So in a 8-bit register we can store 8 bits of data. So starting with 0. Okay, so the bits positions are represented with 0. So 0 to n minus 1, where n is the 8. So 8 minus 1, 7. So 0, 1, 2, 3, 4, 5, 6, 7. So total 8 bits we can store, and that we can represent like this. And the third one is the numbering of bits in a register can be marked on top of box. So its a size it can be represented on the top of the box. So the program counter. So just before we have seen program counter, which stores the address of the next instruction is to be executed, and the size of this program counter is 16 bits. So the size it starts. So always the size we are representing starting from the 0. So 0 to 15, because it is a 16-bit register. So n minus 1, 16 minus 1, 15. So 0 to 15. So by specifying this on top of the box, top of the register, then we can easily say the size of the particular register. And second, last one, a 16-bit register PC is divided into two parts. Bits 0 to 7 are assigned with the lower byte of 16-bit address, and bits 18 to 8 to 15 are assigned with the higher bytes of 16-bit address. So this PC, so actually the program counter is a 16-bit register. So this 16-bit register we are dividing into two parts that are 0 to 7. It is with lower byte of 16-bit address and higher byte is from 8 to 15. So here you can see in the figure the program counter PC of L. L means lower byte. Lower byte of address is stored. So in general, the program counter it is used to store the address of the next instruction is to be executed. Okay. So that means total it contains 16 bits. So the lower 0 to 7 bits are stored in lower byte of program counter and 8 to 15 bits are stored in higher byte of program counter. So in this way we can represent the various registers. And coming to the basic symbols of register transfer language. So already we have seen register transfer language, the definition of register transfer language. So register transfer language is it is a symbolic notation that can be used to describe the micro operation among the registers. Okay. So in this register transfer language, we are using several symbols. So that are the letters and numbers. So it denotes a register. So we can name the registers using the letters, capital letters, and followed by the numbers. Okay. So this is a example MAR. So this is a name of the register using only alphabets, capital letters, MAR, memory address register. Then second one and third one are the alphabets followed by numerical numbers, R1, R2. Second one, braces. So it denotes a part of parenthesis, denotes a part of register. So example R1 within braces 8-bit. So that means it represents the size of that particular register. It is a 8-bit register. Next R1 0 to 7. So 0 to 7 means a total 8 bits we can store in this R1 register. Next arrow, so left arrow. So it represents register transfer. So denotes a transfer of information. So this arrow it represents the transfer of information. So the example R2 arrow R1. So that means the contents of R1 register is transferred to the contents of R1 register is transferred to R2 register. So this arrow it represents the or it denotes the transfer of information from one register to the another register. And the next symbol is the comma. So it specifies two micro operations of the register transfer. So the comma is used to separate two register transfer operations. The first operation is the R3 arrow R2 and the second operation is the R2 arrow R1. So these are the two register transfers. So these two are separated by the comma. So we can write like this R3 arrow R2 comma R2 arrow R1. So in this way we can separate two register transfer operations. As to naming operator, so it denotes naming operator is a colon followed by equal to. So it denotes the another name for an already existing register or alias. Okay, so RA naming operator R1. So that means R1 is the name assigned to the register RA. And next column. So the column alone it denotes the conditional operation. So it denotes the conditional operation. That means a certain operation will be takes place upon satisfying the condition. Okay, so here you can see the example P column R2 arrow R1. So if P is equal to 1, so that means if P value becomes equal to 1, then the contents of R1 register, is transferred to the R2 register. Okay. So These are the various symbols of the RTL, Register Transfer Language. So first one is the alphabets, letters and numbers, parenthesis, arrow, comma, naming operator, colon. And coming to register transfer operations. The register, the operation performed on the data stored in the register is referred as register transfer operations. So the operation performed on the data stored in registers that are referred as register transfer operation. So these register transfer operations are mainly we have three types. The first one is the simple transfer. So that represents R1 arrow R2. So that means simple. That means here the transfer takes place without checking any condition. Simply by specifying like this, that means the R1 contents will be transferred to R2. Okay. So the content of R1 are copied into R2 without affecting the contents of R1. So that means here we are just copying, we are not modifying the contents of the source register R1. Just we are copying. Suppose if the R1 contains some 4, 5. So this 4, 5 we are copying to the register R2. So that means R2 also it contains 42, 45. Okay. So that means the R1 register content will not change. Just we are copying. Okay. So it is an unconditional type of transfer operation. So it is a unconditional transfer because we are not checking any condition for the transfer of data. So simply it is a unconditional transfer. And coming to the second one, conditional transfer. So R1 arrow R2. Okay, R1 arrow R2. So here we have to specify P column. So this is a conditional transfer. P column R1 arrow R2. R1 arrow R2. So that means P column. So already just before we have seen the various symbols that are used in register transfer language. So column is used to represent the condition. So if the P value is equal to 1, then the R1 contents will be transferred to the R2. So that is a conditional transfer. So here you can see the block diagram. So the P value is generated using some control function. Then whenever the P is equal to 1, then the content of R1 register will be loaded into R2 register. And the third one is simultaneous operations. Simultaneous operations. So if two or more operations are to occur simultaneously, then they are separated with a comma. So this is mainly the comma is used to specify the simultaneous operations. So P colon R2 arrow R1 comma R1 arrow R2. So that means here two operations are taking place. So this is one operation and this is another operation. So these two operations they are performing simultaneously, and we can represent both operations simply by using a comma, by separating both operations with a comma. So if P is equal to 1, then the contents of R1 register will be transferred to R2. Similarly, the contents of R2 will be transferred to the R1. And that we can see with a block diagram, that is a control function R2, R1. So R2 content will be transferred to R1 and R1 content will be transferred to R2. And the types of coming to the types of micro operation. So already we have seen what is micro operation. Micro operation are the operations that are performed on the data stored in registers that are called micro operation. So these micro operations are classified into four types based on the operation they perform. So first one is the register transfer micro operation. So transfer binary information from one register to another register. So using this micro operations, we can transfer the data from one register to the another register. And second one is a arithmetic micro operation. So using these micro operations, we are performing some arithmetic operations like addition, subtraction, multiplication, division on the numerical data stored in registers. Third one, logical micro operations. So these logical micro operations are bitwise operations. They perform bitwise micro operations. That means they perform logical operation between two bits of two numbers. So they perform bit manipulation operations on the data stored in registers. So examples of logical micro operations are AND, OR, XOR, clearing register, loading register with all ones. So like that. And coming to the shift micro operation. So they perform shift operations on the data stored in registers. So we have different shift micro operations. Coming to the arithmetic micro operation. So in general, the arithmetic micro operations deals with the operations performed on numeric data stored in registers. So we are performing all these arithmetic operations on the data which is stored in the registers. And the examples of arithmetic operations are addition, subtraction, increment, decrement, shift. In addition to that, some additional arithmetic micro operations are add with carry, subtract with borrow, transfer or load, etc. And these are the symbolic representation of the various arithmetic micro operations. So already we know the micro operations here in the register transfer micro operations are represented using the arrow, this one. Okay. So first one R3 arrow R R1 plus R2. So in this, the contents of R1 is added with the contents of the R2. Then the resultant value is transferred to the register R3. This is a addition. Next one, subtraction. So here the contents of R2 is subtracted from the content of the R1 register, and the register result is transferred to the register R3. Then complement of R2, complementing the contents of the R2. Complementing is nothing but if the register contains 0, it will be converted into 1, and if the register contains 1, it will be converted into 0. Suppose if the R2 register contains 1 0 1 0 0 0 1 1. So the complement of R2 dash is equal to, that means already we have seen 0 becomes 1, 1 becomes 0 in complement. So 1 become 0, 1, 0, 1, 1, 1, 0, 0. So this is a complement of R2. Then R2 dash plus 1. So that means it is a 2's complement to the contents of R2. That means 2's complement means 1's complement plus 1, adding 1. So this is a R2. So simply by adding plus 1, it gives the 2's complement 0 1 0 1 1 1 0 1. So it is a 2's complement of R2. 2's complement of R2 means R2 dash plus 1. Next, R1 plus R2 dash plus 1. So this is a R1 plus the 2's complement of R2. Next, R1 plus 1. R1 plus 1 means incrementing. Incrementing the contents of R1 by 1. So R1 plus 1. Next, decrementing. Decrementing the content of R1 by 1. Suppose incrementing. Suppose the R1 contains 8. By incrementing, it becomes 9. Suppose if R1 contains 5. and if you perform a decrement operation, then it will become 4. So these are the various arithmetic micro operations. And coming to the logical micro operations. So total we have 16 logic micro operations that are clear, and, transfer A, transfer B, exclusive or, nor, exclusive nor, complement B, complement A, NAND, set to all ones. So these are all the various 16 logical micro operations. So AND operation is represented with the symbol and OR is represented with this one OR, and exclusive OR is represented with plus inside the circle. And coming to the shift micro operation. So shift micro operations are used when the data is stored in registers. So these micro operations are used for serial transmission of data. Serial transmission of data. So here the data bits are shifted from left to right or right to left. So in general we will store some data on the registers. Then we are performing certain shift operations on that data. So the data we can shift either from the left to right or from right to left. So either way we can shift the data. So these micro operations are also combined with arithmetic logic micro operations and data processing operations. So mainly the shift of micro operations are classified into 3 types: logical shift micro operation, arithmetic shift micro operation, circular shift micro operation. So in logical shift, again, 2 types. It is divided into 2 types. First one is a logical shift left micro operation, logical shift right micro operation. Then coming to the arithmetic shift. So in arithmetic shift micro operation, again it is divided into 2 types: arithmetic shift left and arithmetic shift right. And coming to the circular shift micro operation. So again here also 2 types are there, that are circular shift left and circular shift right. And coming to the control memory. So what is control memory? So the control memory is the memory which is present in the control unit. So the control unit is present in the CPU, central processing unit. So this control memory is present in the inside the some control unit. So in this control memory, we are storing the some programs, some programs related to the micro program. So the major functional parts in a digital computer are CPU, central processing unit, memory, and input or output devices. So the main digital hardware functional units are control unit, ALU, and the registers. So these are the 3 important parts of the CPU. And the function of the control unit in a digital computer is to initiate the sequence of micro operations. So this control unit, it will initiate a sequence of micro operations, and also it is used to generate timing and control signals, because computer it has multiple modules. So in order to work those modules properly, it requires some timing and control signals. So all those timing and control signals are generated by the control unit. Okay, so the complexity of the digital system is derived from the number of sequence of micro operations that are performed. And we can implement the control unit in 2 methods. The first method is a hardwired control unit. It is the method we are implementing the control unit with the help of hardware components like encoder, decoder, logic gates, multiplexer, demultiplexer. So using all those hardware, we are implementing the control unit. That is called hardwired control unit. And another method is the microprogrammed control unit. So microprogrammed control unit is the control unit in which the timing and control signals are generated with the help of microprogram. That is called the microprogram control unit. So the hardware control unit is the fastest way to generate the timing and control signals when you compare with the microprogrammed control unit. But the hardware control unit is it doesn't have any flexibility to modify the instructions, because if you want to modify the instructions, then um, we need to change more hardware. So that's why it is not that much easy. But in the microprogrammed control unit, it is more flexibility to modify the instructions, because with the help of the program, we can easily done. Thank you. So in this lecture, we have seen various definitions and terminology. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.